given that y equals log base a of x, where x is greater than 0 and a is a positive constant, express x in terms of a and y. So basically we need to make x the subject here. So we need to do the inverse operation of log base a, which is a to the power. So I'll do a to the power of both sides of this equation. So I'll get a to the power y. The a to the power log a will cancel out, and I will just get x on the right hand side. So x equals a to the power y. That's me expressing x in terms of a and y. Part II. Deduce that ln x equals y ln a. So we are continuing from our answer in part I here, and we're introducing logarithms. So we're going to take logarithms of both sides now. So I'll do ln of a to the power y equals ln x. I can then use the laws of logarithms to take this power and move it down the front here. So I'll get y ln a equals ln x. So that's part II done. Part B. Show that dy by dx is equal to 1 over x ln a. So we're differentiating. So what I'm going to do here, I'm going to rearrange this to make y the subject. So I'm going to divide both sides by ln a. So I'll get ln x over ln a. So that's me just dividing both sides by ln a, which is just a number. Remember, a is just a positive constant, so ln a is just a number. Now, in order for me to differentiate this, I'd like to write it in a slightly different form, just to make it a bit easier for myself. I'm actually going to rewrite it as the 1 over ln a times ln x, just so I can keep the x function a little bit separate to the constant, just to help me with the differentiation. So dy by dx is equal to, well, I've got the 1 over ln a at the front there, that's a constant, multiplied by the derivative of the ln x, which is 1 over x. Differentiating the ln x gives me 1 over x. The constant at the front there stays exactly the same. Timesing those two things together, we get the desired result that we needed to show. Right, moving on to part C, we're told that the curve C has got the equation y equals log base 10 of x, where x is greater than 0. We're told that the point A lies on the curve and has the x coordinate 10. Using our result in part B, so using the fact that the gradient function is 1 over x ln a, in this case our a is 10, finds an equation for the tangent to C at A. So, equation of the tangent, we're doing y equals mx plus c. We want the gradient. So we can use our answer from part B to get our gradient function. So we've got 1 over x ln, and like I said, a is 10 now. So this is my gradient function. And we want the gradient when the x coordinate is 10. So 1 over 10 ln 10. That's the gradient of my curve at that point. I can now do y equals m x plus c. Excuse me. And I want the coordinate. I know the x coordinate was 10. I need to know the y coordinate so I can substitute that in as well. And that's fine because I can put 10 into my original equation here to get the y coordinate. Y equals log base 10 of 10, which is 1. So when x is 10, y is 1. So let's substitute those into my equation. So 1 equals 1 over 10 ln 10 times 10 plus c. We can see the 10s here are going to cancel out. And I'm now going to, actually let me rewrite this so it's a bit clearer. I'm now going to take the 1 over ln 10 away from both sides to get the c. So I can now say that the equation of my tangent is y equals mx. So y equals m x plus c. Excuse me. And that is the equation of my tangent when x is 10. We are then told that the tangent to the curve at A crosses the x-axis at point B. So x-axis, that's when y equals 0. So our tangent to the curve at A, let's make y equal to 0 here and solve this. So first thing I think I'm going to do to make this equation a bit simpler is I'm going to multiply each term here by 10 ln 10 to get rid of this awkward fraction. So we'll times the left-hand side by 10 ln 10. We'll times here by 10 ln 10. By here 10 ln 10 and times here by 10 ln 10. So 0 times 10 ln 10 will be 0. These will just cancel out and leave me with a x there. Then we have the 1 times 10 ln 10. And then we have the 1 over ln 10 times 10 ln 10. So they cancel out and just leave me with a minus 10 on the end there. Therefore, I can now say, if I move the 10 and the 10 ln 10 to the other side, I can see that the x-coordinate of point B is 10 minus 10 ln 10. That's my answer for part D.